Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating collection of papers, covering a broad spectrum of computer science topics. We've got everything from Kalman filters to the intricacies of the Windows kernel, and even a peek into the world of LLMs. Ready to jump in? Enthusiastically?
Absolutely. Let's start with something fundamental. I'm particularly interested in the paper on Kalman filters. What's the core idea presented there?
That paper provides a simplified, intuitive derivation of the Kalman filter. It breaks down the complex mathematics into manageable steps, making it accessible to a wider audience. It's all about recursively estimating the state of a dynamic system, by combining predictions with noisy measurements. Think of it like tracking a moving object using a sensor. The filter cleverly weighs the predicted position against the actual sensor reading to get a more accurate estimate.
So it's essentially a weighted average, but with a clever way of updating the weights based on the uncertainty in both the prediction and the measurement?
Exactly. The beauty lies in how it handles uncertainty using covariance matrices. It's a recursive process, constantly refining the estimate with each new piece of information.
Interesting. Now let's shift gears to something a bit different. There are several papers here on GPU programming and optimization. What are some of the key challenges and techniques highlighted in those papers?
There's a lot on that. Many papers discuss maximizing parallel processing efficiency on GPUs. Challenges include optimizing memory access patterns to minimize latency, effectively utilizing shared memory, and managing thread synchronization. Techniques range from careful data layout strategies to using specialized instructions like warp shuffles. One paper even delves into the intricacies of cache allocation technology on Intel architectures.
I see. So it's not just about writing parallel code, but also about understanding the underlying hardware architecture and exploiting its specific features for optimal performance?
Precisely. It's a deep dive into hardware-software co-design. Another interesting aspect is the exploration of different parallel programming models and their suitability for various tasks.
And what about the papers on LLMs? What kind of insights do they offer?
Well, there are a few papers on large language models, focusing on different aspects. One paper discusses training techniques for LLMs from scratch, highlighting the challenges and best practices involved in scaling up the training process. Another delves into the architecture and efficiency of specific LLMs, like LLMA, emphasizing their open-source nature and potential for further development. There's also work on improving inference speed through techniques like quantization.
So it's a rapidly evolving field, with ongoing research into both training and optimization of these massive models?
Absolutely. The papers here represent a snapshot of the current state of the art, but the field is moving incredibly fast. We've only scratched the surface of this rich collection of papers. But hopefully, this gives you a taste of the diverse and exciting research happening in computer science.
Definitely. Thanks for the insightful overview. It's been a fascinating journey through these papers.
My pleasure. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of computer science research. Until next time, goodbye.
Bye-bye.